Okay, this is another class. It's your boy Action Sunday. So as I promised after class 8 that we are going to take some exam questions, and these are few of the exam questions relating to exponential equations that will be applying some laws of indices and also logarithmic equation and their laws. So you can try to attempt these ones. I think okay, for the exponential equation we haven't really touched. I intentionally jumped number 1 as part of an example for a reason. We are going to treat that. Then also we'll treat number 2, then that's of logarithm. We are still trying to apply some of the laws. So this question 1 and 2 under solving for individual equation will help us to bring out the points on logarithmic expressions and how it can be introduced and use it to solve for variable having powers. So stay put as we solve number 1. So here is the beginning of number 1, the solution. So you can see you are having the expression. The first thing you do is to put the expression in such a way that you can actually make y to be a value of an expression. However, if you do not convert or try to rearrange the expression, it might be pretty difficult for you. You see what we have just done. This from the law of indices, that this expression is the same as this first one. Then remember another law of indices, that when you have plus, it simply means multiplication, but you are only taking the power and picking one of the base. That is what this, it was from this expression that we got this. Just try and practice it, you get used to it. Then we have the other expressions remaining. So now we can take this 5x and say let y equal to 5x. So this moves us to the next aspect, and you can see how the expression goes. Here we now have the y squared, because the 5x is actually raised to power 2. That is 5 raised to power x raised to power 2. But remember, we did not include the raised to power 2 when we were saying 5x should represent y. It was just only the 5x. So that is what we have here, 5x as our y. Then this 2 is what we are having here. Anything raised to power 1 is that same thing. So we are having 5. Remember, it is multiplication. We have our other expression, but in place of this 5x, we are still putting y plus 5 equal to 0. So now, multiplication is associative. So whether you say y square 5 or 5y square, same thing. But to make your expression cool, you can leave it as this, and we go ahead to say 26y plus 5 equal to 0. So there are 2 ways you can actually solve this, and I gave the 2 expression. You can use the formula method or the normal factorization for algebraic equation. Now look at the normal factorization for algebraic equation, where you have ax squared plus bx plus c, where this your a, b, c, they are constants. But when you want to factorize using that product rule I told you, you see this p and this arrow, they are actually constant for x. I will explain that further later when we want to treat this, we want to factorize this. Then y, the q and s, they are still their normal constant. Or we can use the formula. If we have this algebraic expression and we want to get the value for x, just this referred to as almighty formula. I don't know why they call it almighty, but if you can remember in secondary school, there's a formula like this: minus b plus or minus the square root of b squared minus 4ac all over 2a. Everything all over 2a, where a, b, c are constant. So for this expression now, this is our a, this is our b, this is our c, if you wish to do it. But I am applying one. You can still apply to the formula. You will discover that your answer will still come out the same. Now, I'm trying to apply this formula 1 for this expression: 5y squared minus 26y plus 5 is equal to 0. Now look at it. I know you're already seeing part of the answer, but you can just pause the video and try to solve if you can get it right. Now this is what I want to express for you, what this particular expression is trying to give out here. It's telling you, first thing first, as I told you, when you open your brackets, you put y and y. Previously, the ones I've been solving, you discover that the y, it's usually just 1. There is no coefficient at the back or a constant at the back. It's usually 1. They don't put a value. So if it's just 1, you are not too bothered about what is behind your x or your y that you are using. But when you have a constant or a value that is above 1, from 2 to 10 to 20, just know that first thing first, instead of just putting xx or yy as the case is here, what will you multiply together to give you 5? That will be 5 times 1, meaning one side will be 5y, the second side will be just y, because both coefficients will be 1. Now this is where the trick is. When we come to this aspect, remember I told you, you use the product rule, that it is what will you multiply together to give you this, at the same time add to give you this. For the fact you have a value here now that is no longer 1, that is 5, you use this value 5 to multiply this that is here, making 25. It is the mindset of 25 that you use to determine this. So what will you multiply together to give you 25? It's simply 25 times 1. Then if you add 25 and 1 together, it should give you 26. But this time around, for the fact we are having minus 26, it simply tells us our 25 will be carrying minus, our 1 will also be carrying minus, so that when you even multiply both together, it will give you a positive 25. Or I don't know how to explain this better. You don't look at this as 5 again because of this. If this were just 1 or just y squared, then we'll consider this as just 5. But for the fact it is 5 here, we'll solve the initial part of it. Then this one is supposed to, you express it as 25 in your mind. So this is the final expression to get the factors out. If you wish to confirm how it is being done, just take your time to actually multiply or open the bracket. You discover you return back to this. So as I told you initially, this is 5y and y. When the two meet together, it will result to this. Y, for this last one, it's in your mind's eye, it is 25 that is here, and you use the 25 to determine whatever is here. So even when you are leaving your value here as 5, you already know that when this 5 meets up with this 5, it gives you 25. And when you also add up with this one, it will give you 26. You just need a constant practice. Maybe you find more questions to solve so you can get this, or just stick to the formula. It will give you the same answer. So as you already know, equate this to 0 or this to 0. and when it passes the equality sign, it turns into a positive number. If it were to be negative, it turns into a positive also. So we've gotten our expression for y. For this now, when 1 passes, it turns to 1, this passes, it turns to 5. Then you divide both sides by 5 for you to have 1 over 5. And for this, there is nothing you are dividing. This expression is correct. But recall, we said let y be equal to 5x. Well, 5 raised to power x. We were the one that brought this variable. So let's introduce 5x in place of y and see what our final answer will be. So when we put our 5x in place, remember from the law of indices, I told you 1 over simply can be represented as raised to power minus 1. If we want to express this 5 raised to power minus 1, we can also express it as this. We are doing this so we can work with powers that x we have a value, or this 5 raised to power 1 is that same 5. So 5 cancels out when we give the expression like this, and x is equal to 1. So x is either minus 1 or 1. This is the final answer. So let's move over to solving question 2. Now look at question 2. Pretty straightforward and easy. Just apply the same method. This doesn't look too complex. Apply the same method you used in the previous one. You rearrange, you have it as this. For this, you are only doing what you did in the place of 5 in the previous question, and you have this. This expression here comes out as this at the end of the day, equal minus 8 equal to 0. So we are letting y, you can choose any variable as I told you, or alphabet. It's equal to 2 raised to power x. So the 2 raised to power x now, we can have it as y in the expression. So you can see from there we are able to get a proper expression. Y squared plus 2 minus 8 is equal to 0. So now can you try to factor out? This time you don't have any coefficients behind y squared. So try to do it. You can pause the video and try solving it. So it's practice section. So even when you are not correct, but look at it. What will you multiply together to give you 8? It is 2 times 4, right? It's 8. When you add or subtract 2 from 4, it will give you 2 definitely. So you know it is 2 and 4. That should be your factor. And when you equate both to 0, you discover that y minus 2 equal to 0, or y plus 4 is equal to 0. Then the 2 crosses over, the equality sign turns to positive. Y this positive crossover, it turns into negative. So you recall that you said y should be equal to 2x. You introduce the y, not from the question. So replace whatever y is in place of your expression, which is this and this values. You have this to be this. This 2 is the same as raised to power 1, so the 2 can cancel out, while your x can come out as 1. Why for this? For the fact you have a negative sign for this, even when we try to re-express this to have a power, because 2 raised to power 2 simply means 2 times 2, which is 4. The 2 cannot cancel out because of the negative, and it simply means there is no solution. You cannot say x is equal to 2. So this for this. In the next class, we'll solve the other logarithmic equations.